Alrighty, everybody. So, this topic is topic 1.4, and I actually have it broken down into two parts. So, this is really the hallmark of economics, and in fact, this and the next part 2 and then topic 1.5 are all part of chapter 3 in your textbook. So, it's a really big chapter. If you have any background in economics, or if you think about some economic topics, one of the first things that might pop into your mind is the idea of supply and demand. This is where a lot of economics classes start. So we are going to dive right in. So this first topic, 1.4.1, is just introducing you to the supply and demand model, and then 1.4.2, called supply and demand shifts, is going to be us using and manipulating the model a little bit. So, recap from last time. This is more information from that topic 1.2, economics as a science. So we have a new model, a new simplified version of reality. We're going to use our ceteris paribus, all else equal assumption again, just like we did in the previous topic. Supply and demand we can show as a graph. I want you to be able to recognize supply and demand graphs. And understand the relationships between the variables in my graph. So the key questions for this topic are going to be, what are the fundamentals of markets, what determines demand, what determines supply, and then what happens when we put them together. And essentially it'll tell us how the price of something is determined. So the first key question are the fundamentals of markets. So markets typically break down into two groups. There are firms. That's just a fancy way to say a business. These are the folks who supply goods or services. So a good is something you can reach out and touch. A service is something that you buy, but you can't exactly reach out and touch, like going to see a doctor, something like that. Consumers, those are the people who purchase items. I also call them buyers a lot of the time. For firms, that first group, sometimes they're called suppliers or sellers or producers even. So lots of these groups have different names. So firms and suppliers, and then consumers or buyers. And these two are going to meet up and exchange. So a market is anywhere that these two groups meet up and trade with one another. Now, we've talked about trade up to this point in terms of barter for the most part. But most of the trades we make in our everyday lives, whether it's going to the grocery store, a restaurant, to buy some toilet paper, or even paying tuition at a college, happens using money. And everything has a price. So this is going to tell us, why are certain things more expensive? Why do prices fluctuate? And essentially it's going to be the interests of those firms and those consumers, the supply and demand, that come together to determine a price. So like I said, a market is anywhere where my two groups, my buyers or consumers and my sellers or my firms, meet up and exchange. It does not have to be a physical place. It can be. So if you think of a farmer's market or a grocery store, those are definitely examples of markets that has our components, buyers, sellers, and exchange. But also websites like Amazon, eBay, those count as markets. Even when you swing by a vending machine and buy a snack, that is going to be a market, as long as it satisfies those components on the last slide. All right, so in addition to our definition of market, for now, we are going to assume that most markets are competitive, sometimes called perfectly competitive or perfect competition. So for a market to be a competitive market, in addition to being buyers and sellers and exchanging happening, you need to satisfy these following conditions in the smaller bullet points below. Not only are there buyers and sellers, but there are many buyers and there are many sellers. That means if you are participating in the market, you have lots of options who to buy from or who to sell to. You do not have to pick from a small group. You've got lots of options. Next, all of the goods have to be very, very similar or almost identical. So a really good example of this would be like produce at a farmer's market. Pretty much a small red potato is a red potato. It doesn't matter if I buy it from one farmer or the other. They're pretty much the same. There's not a lot of branding that goes on there. And when you put those two conditions together, this third one follows really naturally. It kind of sums the other conditions up. No one individual has an influence over the price. So, for example, if we have a farmer's market and everybody's selling, let's say, Granny Smith apples, and the going rate for a bag of apples is $1. If one seller tries to raise the price to, say, $2, everybody's just going to go to all the other sellers around him. He doesn't have individual influence over the price. Same would go as consumers. If there's lots of buyers in a market and one consumer tries to talk a farmer into selling his bag of Granny Smith apples for less than $1, that farmer's just going to tell him to go away and sell it to the next guy who's willing to pay $1. So competitive markets, no single individual is going to have an influence over the price. All right, so not all markets are competitive or perfectly competitive. Sometimes they are imperfect. We say a market is imperfect when one of those groups, buyer or seller, has influence on the price. We typically talk about it from the seller's perspective. A lot of times sellers do have control over the price, and we call that ability to influence price market power. And there's different degrees of market power. So there can be a little bit of market power if their product isn't totally identical. There can be an extreme form of market power when you're the only seller selling a really unique product. And in that case, we say that market is a monopoly. So a monopoly is a single company that supplies the entire market for a good or service. Monopolies are actually pretty rare. A good example, though, of something or a market that's close to a monopoly would be the De Beers Diamond Company back in the 80s. They owned a lot of the world's diamond mines, therefore they had a lot of market power and were able to influence the price of diamonds. All right, so that's key question number 1 finished. Now we're going to talk about demand. So these definitions here are pretty important. So demand is the amount of some good or service that consumers are willing and able to purchase at each price. So this is your book definition, and it's a great definition, but I like to kind of summarize demand and say demand, let's see, where's my pen? Demand is a relationship. Not like a dating relationship, but like a relationship or connection between two variables. And the two variables that demand connects are these two other bullet points on the page, the orange ones. Price, what a buyer pays for a unit, and the quantity demanded, or QD for short, the total amount that someone wants to buy. So this is a good definition, the amount of some good or service that consumers are willing and able to purchase. It's a fancy way of saying quantity demanded at each price. There's our second variable. But a shorter definition would be relationship between price and quantity demanded. That's kind of the short way of thinking about it. So, a few things about demand. These words are underlined, willing and able to purchase. So a lot of times as consumers, we distinguish between want and need. But as far as demand goes, those things are going to be the same. Whether you really want something or really need something, as long as you are willing to buy it and able to purchase it, you have effective demand for a product. Okay, so demand is this complex relationship between these two variables. This bottom portion where I say demand does not equal quantity demanded, this is a really common mistake that my students make, and students make it in most economics classes. Demand, as we wrote over here, is this complex relationship, whereas quantity demanded is a single number. So let me give you an example to kind of clarify the difference between these two. Let's suppose I have toilet paper. Basically gold during this time of coronavirus. And let's say if I were to make a little table, I have different prices that I could sell the toilet paper for, and at each price I get a different quantity demanded from folks. So let's say I could sell toilet paper for $10 a roll, $5 a roll, or I could give it away for free. Okay? Let's say if I try to sell it for $10 a roll, Only 2 people are interested in buying it. If I drop the price to $5 per roll, maybe now I get 4 people who are interested in it. The quantity demanded of toilet paper is 4. If I start giving it away for free, let's say 10 people want it because there's a shortage. My market, I guess, is fairly small. All right. So people want to say, this is the mistake my students make. I say, when the price of toilet paper is $5, my students want to say the demand for toilet paper is 4. That's wrong. When the price is $5, we say the quantity demanded is 4. Okay? So when it's a single number that corresponds to a single price, it's quantity demanded. When we're talking about this whole relationship, all the prices and all the quantities demanded, this big list, that's demand for toilet paper. This number right here is quantity demanded. And this is a different quantity demanded. And this is a different quantity demanded. So, singular amounts are quantity demanded. All of the quantities demanded with all their corresponding prices, that is demand. It's a complex relationship. So I hope that makes sense. All right, so with demand, there is this thing called the law of demand that says something about our relationship between price and quantity demanded. It says, ceteris paribus, all else equal, there is an inverse or negative relationship between price and quantity demanded. So that's just a fancy way of saying all else equal, if we keep everything the same and the price of an item increases, quantity demanded falls. Right? So if everything stays the same and a product gets more expensive, people want to buy less of it. Vice versa, if the price of an item falls, all else equal, people will want to buy more of it. Now you might be thinking to yourself here, hold on a second, I can think of plenty of instances where something gets more expensive and more people want to buy it, right? If we talk about that toilet paper example I was talking about just a second ago. True, right now toilet paper is probably getting more expensive and there's high demand for it. But the key phrase here is ceteris paribus, all else equal, okay? Here, because of coronavirus and lots of shortages going on, all else is not equal in the toilet paper market. If everything was the same and the only thing we manipulated was the price, we'd see this relationship emerge. So that's my law of demand. All right, so we can show demand in 2 different ways, in a demand schedule or a demand curve. So a demand schedule is just a bunch of prices and quantities demanded in a table. So that's the short definition. A demand schedule is a table. And a demand curve is if we put that information from a table on a graph. So we always put the quantity demanded along the bottom axis and the price on the y-axis. And we'll look at an example of each. So here's an example of my demand schedule for gasoline. So you can see this law of demand at play here. Over here, at the higher price per gallon of gas, I'm going to have a lower quantity demanded. And then as we move down this table here, when we get to the low price per gallon, my quantity demanded is high. So there's that inverse relationship we were talking about. Funnily enough, I used to use these numbers in class, and people always thought that it was really crazy that I used such low prices for my example here. But in recent times, with all the low gas prices, since everyone's following stay-at-home orders, my example here makes a lot more sense. All right, so here is an example of a demand curve. All I did was I took the information from the table on the previous slide, and I made them little points on this graph. Here we can see the quantity demanded along the bottom here, and we have the price up here. And so each little point just represents a row in my table. So that first row, the price per gallon was, let's see, what was it? $2.20. And my quantity demanded was 2. So this first point on the graph, at a price of $2.20, quantity demanded is 2. And then the second point represents the second row. So a lot of times with a demand curve, I'm not actually going to put these individual points here. I'll just put this blue line itself there. But always remember there are individual points that created that line in that model of demand in the first place. So this line, this curve, always points downward, and the reason it's always going to point downward is because of that law of demand, the fact that there's an inverse relationship between price and quantity demanded. So demand curves always are going to point down like that. So we can show the law of demand too as we move from one point to another on the graph. So let's say, for example, we're starting at this point. When the price is $1.60, my quantity demanded is 8. If price were to increase to, say, $1.80, I'd move to this point on the graph, and my quantity demanded would be lower at 6. Vice versa, moving this way down the graph, if prices were to fall, quantity demanded goes up. So no matter which direction you move, up into the left or down into the right along a demand curve, it's going to show that inverse relationship because of the slope of the line. All right, so a lot of times when we look at demand, we don't want to just look at one person, my demand for gasoline, but we want to define a whole market. So maybe we define our market as the city of Orlando's demand for gasoline. Then we would just add up everybody's quantity demanded at a bunch of different prices for each buyer to get something called the market demand. So here's an example. Let's suppose that we have this very small market that only consists of 2 people, myself, Lily, and let's say Melissa. So I've got my demand schedule, Melissa's demand schedule. We add across here. That's why that last slide, that last definition said horizontal sum, and we're able to get the market demand. So at a price of $2.20 per gallon, my quantity demanded is 2, Melissa's is 1, market demand is 3. Because 2 plus 1 is 3. At the price $1 per gallon, I'm going to demand a quantity demanded of 14. Melissa's quantity demanded is going to be 13. Add it together, market demand, we get a quantity demanded of 27. All right, so when we're looking at a graph, and when we're discussing a change in a market, a change in demand or quantity demanded, again, we don't want to confuse quantity demanded for demand. So quantity demanded, when we show that in a graph, it looks like a movement along a demand curve from one point to another. And quantity demanded changes when we see a change in the price of the good, whose demand model we're looking at. On the other hand, a change in demand, remember demand is the more complex relationship. The way we're going to illustrate that in our graph is we pick up that blue line and we'll shift it to the left to show a decrease in demand, or we'll shift it to the right to show an increase in demand. That happens when we change something besides the price of a good. So these are going to be easier to understand with some examples, so I have a couple on the next slide. So here, just visually, is what I'm talking about when I talk about a movement along the curve. So when the price of an item changes, we can shift to new points on that curve, that demand curve here. And when we talk about a change in demand, that's when we change something besides the price of an item, and we pick up the whole line and move it to the left. That's a decrease in demand, or we move it to the right. That would be an increase in demand. So here is an example. Let's suppose that currently we are at point A on the graph. Let's say the price for a package of Oreos is $3, and in my market that leads to a quantity demanded of 4. Now if we have this event, the price of Oreos falls, I don't know, let's say to $2. What is going to change? Demand or quantity demanded, and how do we illustrate it? So I'm going to go back here. When I change the price of a good, we say the quantity demanded will change, and we're going to show it as a movement along the curve. So the way I would show that here is I'm going to move from point A to a point that's down into the right along this demand curve, something like point B, and my quantity demanded will increase, let's say from 4 to 5. So the answer to this question, if I said what changes when the price of Oreos falls, the correct answer would be quantity demanded increases because it went up from 4 to 5, this amount down here along the bottom of the graph. So a wrong answer would be demand increases, even though it might be tempting. Remember, demand's the whole thing. All right. So if we try another similar question, when we're talking about the market for movie tickets, let's say hypothetically, the price of movie tickets increases. Again, we're changing the price of my item here. An increase in the price is going to move us up and to the left along my demand curve to a point maybe like this. And the result would be the quantity demanded is lower, right? Because we're moving along this point of the graph. You didn't have to know that it fell from exactly 3 to exactly 2, but if you marked a point up and to the left along the graph, you would see that the quantity demanded is lower than our starting point A. So I would need you to know that quantity demanded decreases here. So that's pretty much everything for demand. Now moving on to supply. So supply is the complete opposite side of the market. And generally speaking, students have a harder time relating to supply versus demand because most of your interactions in the market have probably been as a consumer on the demand side of things, so the law of demand makes sense to you. So when you think about supply, I want you to think like a seller. And there's probably at least one market where you have been the seller of something, and that is in the labor market. So when you go to get a job, you are supplying, you are selling your time and your effort and your skills. So it might be helpful to relate supply and the relationship between our variables to you as a worker. So supply, just like demand, it is a relationship. So demand, we said, was a relationship. Supply, also a relationship. And it's a relationship between two variables, the price variable and the quantity supplied. So that quantity supplied, or QS for short, is the total number of units of a good or service that producers are willing and able to sell at a given price. So again, supply is the complex relationship, quantity supplied is a single amount. So another example here, let's just say hypothetically, I am looking to hire some tutors in economics. So I can offer different prices, let's say per hour, that I'd be willing to pay you guys. And then however many tutors I got out of the class, that would be my quantity supplied. So I could offer to pay you guys $5 an hour, and I'd probably get no takers because you can probably make more somewhere else. I could offer $10 an hour, and maybe I'd get 2 people who'd be willing to tutor. And if I were to offer $15 an hour, let's say I got 4. Again, the quantity supplied is any one of these single amounts that corresponds to a price. And this whole relationship, all the prices and all the quantities supplied, that is our supply of tutors in the market. So when the price of tutors is $10 per hour, or let's say the wage, that's a fancy way of saying the price of labor, we call it a wage, we'll say the quantity supplied of tutors is 2. So a single amount, quantity supplied, the whole thing, supply. So again, try not to get the two confused. So just like with demand, we have a law of supply here, but it's kind of the opposite. So the law of supply tells us, ceteris paribus, there is a direct or a positive relationship between price and quantity supplied. That means all else equal, if the price of an item increases, that means sellers are going to want to sell more. All else equal, if the price decreases, sellers will want to sell less. And we saw that in my tutor example, right? It was pretty obvious when I was trying to get more tutors, the obvious solution is to offer to pay more. So we can show that relationship of supply one of 2 ways. We can show it in a table. If it's in a table, we call it a supply schedule. And if we were to put it in a graph, we'll call it a supply curve. So here's an example of one gas station's potential supply schedule for gasoline. So when the price of gas is higher, say $2.20 per gallon, let's say Shell gasoline, this one firm, is willing to supply 72 gallons of gas, so higher price, high quantity supplied, versus when the price per gallon is low, say $1 per gallon, their quantity supplied is only 50. And the reason for that is that same idea, opportunity cost, right? It costs time and effort to supply and sell gallons of gasoline. And just like buyers respond to incentives, sellers do as well, and a price serves as that. So just like with demand, with supply, we want to look at the whole market supply, so not just one gas station. On the last slide, we were looking at the supply schedule for one gas station, Shell Gas, but we want to look at all of the gas stations and all of their quantities supplied. So here's a potential example of that. This is actually from your textbooks. So you can see here, I don't have a beautiful straight line like I did with demand. It's kind of bendy and curved, and that's why they are called demand curves and supply curves. A lot of times we draw them as perfect straight lines, but in reality, the information doesn't always make a beautiful line that points up or a beautiful straight line that points down. They do curve a little bit. And what I will say, though, is that it's very clear that this line has positive slope, an upward slope. It points up along the graph. That's going to be true of all supply curves. It illustrates that law of supply, that at higher prices on the graph, we're going to have higher quantities supplied, and at lower prices on the graph, we're going to have lower quantities supplied. So that's going to stay true. All right, again, we want to know the difference between a change in quantity supplied, which is a single amount. We show that as a movement from one point to another along the curve caused by a change in the price of an item, versus a change in supply where we pick up and move the entire line. The entire curve can shift to the left as a decrease or to the right as an increase when I change something besides the price. Now you might be thinking back to the demand that we just discussed, how we didn't look at any specific examples of shifts in demands and shifts in supply, and that's just fine. When we look at part 2, shifts in supply and demand, that's when we're going to discuss what those non-price factors are that shift supply and shift demand. So here's roughly what it looks like. So when the price of an item changes, we're going to move either up and to the right along a supply curve or down and to the left along a supply curve. And this amount, which we call the quantity supplied, will fluctuate. When we change something besides the price, the entire curve will either shift to the left as a decrease or shift to the right as an increase. So that's going to be the rule for both supply and demand. If I pick up the line and I move it to the left of the original, it's a decrease. If I pick up the line and move it to the right, it's going to be an increase. So we're going to put supply and demand together now. So both my graphs for supply and for demand had price along that y-axis and the quantity along the x-axis. So we can put them on the same graph, and they're going to intersect with one another. So that intersection point is how the price of a good is determined, through both supply and demand, those forces coming together. So when we put those two together, we get something called an equilibrium. So an equilibrium is the combination of price and quantity where there's no economic pressure that would cause price or quantity to change. So that's just a fancy way of saying equilibrium is the market's happy place. It is where there's not too much, there's not too little, there aren't shortages, there aren't surpluses. The price in the market makes sure that everybody who wants to buy that good or service can find it, and every seller who wants to sell that good and service can find someone to sell it to. So it's like the market's happy place. It naturally gravitates towards this point. And the idea that supply and demand gravitate towards this point is called the law of supply and demand, that the price of a good will adjust to bring the quantity supplied and the quantity demanded into balance. So, equilibrium price and equilibrium quantity, those are just the corresponding points on the graph that match up to that intersection point of the supply and demand curve. We'll look at an example here in a minute. Sometimes the equilibrium price is called the market clearing price. And the quantity is going to be that point that corresponds to the point on the supply curve and the demand curve. So the quantity demanded and quantity supplied are the same. Okay, so here's an example of an equilibrium. So as you can see here, I have my downward sloping demand curve, a bunch of corresponding prices and quantities demanded out along these axes. I've got my upward sloping supply curve. This represents all the sellers in the market for gallons of gasoline. Where they intersect, this is my equilibrium point. So at this point in the graph, given supply, given demand, the price per gallon is going to be $1.40 per gallon, and the equilibrium quantity is going to be 600 million gallons of gasoline. I could also give you a supply and demand schedule and ask you to find the equilibrium point here. This is a little bit trickier than just looking at where two lines intersect on a graph, but I bet you guys could do it. You just need to see where the quantity demanded is equal to the quantity supplied, so where these numbers match up. Hopefully you guys can see it's right here. So at this point, the equilibrium price, again, is $1.40, and my equilibrium quantity is 600 million gallons of gas. That's where those two are equal. So at this point, I have a little video here. So if you go to supplemental video tutorials for 1.4.1, there is a clip about the equilibrium process from the show Pawn Stars. So you can pause this video, go check out that one, and then come back here. Alright, so if you watched that Pawn Stars video, you saw that a lot of this equilibrium process, bringing supply and demand into balance, is kind of organic. It's throwing out prices, it's the buyers and the sellers pushing against each other until they reach that agreement and they shake hands in the video. So it's a really good example of how those conflicting interests can come together to create a market price. So we can also think of supply and demand as equations. So if you remember from algebra class that every line on a graph has an equation that corresponds to it. So here are two hypothetical equations. So we could say the equation for a demand curve could be QD, or the quantity demanded, is equal to 90 minus 3P. So QD would be my quantity demanded, P would be price, and this whole equation is my demand equation. We'd say the quantity supplied is represented by this equation. QS, or quantity supplied, is equal to P plus 10. And then we can solve for the equilibrium. So I'm going to jump over to my sketch pad, do some erasing here. So I have some space, and I've got my two equations here, the quantity demanded and quantity supplied equation. And so if I want to solve for the equilibrium, I can use my definition that I used to find equilibrium on the previous way with the table. So we know equilibrium is where QD is equal to QS. So I'm just going to plug in 90 minus 3P for QD. So I'm going to put 90 minus 3P on this side of the equal sign. And then on this side of the equal sign, I'm going to put my equation for QS, P plus 10. So now that I've set these two equal to each other, I can rearrange the equation and solve for P. Whatever I get for P is going to be my equilibrium price. So if you don't have a lot of experience with algebra, essentially here, whatever I do to one side of the equal sign, I have to do to the other to keep them equal to one another. So I can add, subtract, multiply, divide, and my goal here is to get P by itself on one side of the equal sign so I can figure out what P is equal to. So I'm first going to get rid of this minus 3P, and so I get rid of minus 3P by adding 3P to both sides. So they're going to cancel out over here. So on this side of the equal sign, all I have left here is 90. So I've got 90 equals, and I've got P plus 3P, that's 4P, and then I've still got this plus 10 over here. So now I want to get rid of this plus 10. I get rid of it by subtracting 10, and I got to do it to both sides. So these guys cancel out over here. 90 minus 10, that's 80. And then I've got 4p left on this side of the equal sign. Now I want to get p by itself, and I have 4p is equal to 80. So if I divide both sides by 4, then I can get p by itself. So these guys will cancel out. 80 divided by 4, kind of running out of room here. 80 divided by 4, that's 20, and that is p. So we'll say the price here, my equilibrium price, is going to be $20. Bam! I found my equilibrium price. But I still have to find my equilibrium quantity. So once you find your equilibrium price, the way to find the equilibrium quantity is to just plug it back into one of these two equations. And it actually doesn't matter which one, whether you solve for quantity demanded or quantity supplied, because we know at equilibrium they're going to be equal to each other. So actually, as a way to check yourself, go ahead and plug it into both equations to make sure you get the right answer. So here, for quantity demanded, I've got 90 minus 3p, and p is 20, so I've got 90 minus 3 times 20, or 90 minus this guy becomes 60, and so my price here, my quantity demanded is going to be 30. And then over here, I'm going to erase a little bit so I have some more room. If I were to plug it into this equation, I've got p plus 10, and I know p is 20, so I do 20 plus 10. That's also 30. So they both match. That means I got the right answer. So my equilibrium quantity, or QE, is going to be 30, and my equilibrium price, or PE, is going to be 20. So that's kind of the trickier way to solve for equilibrium, but that works as well. All right, so we're going to talk briefly about what happens when a market is not in equilibrium. So quantity demanded does not always equal quantity supplied, because sometimes strange economic events that cause things like shortages of toilet paper at the grocery store. So that's our first term I want to define. So a shortage occurs when the quantity demanded is greater than the quantity supplied. So the amount people want to buy is greater than the amount sellers want to sell. That's what we have at the grocery stores right now, or grocery stores or department stores. You can't find any toilet paper because people want to buy more than is available to sell. So the reason a shortage occurs is because the price is too low. It's below the point that would clear the market. And when the price is really low, buyers want to buy a whole lot, but sellers aren't enthused about selling a whole lot. And so that law of supply and demand will tell us that so long as the market is allowed to, the price will rise over time until the shortage is fixed. Now we have in topic 1.5, price controls, an explanation that here in the United States, or here in Florida and in many states in the United States, we have some laws in place that prevent that equilibrium process from happening. And that's why we have these persistent shortages during this time. So we'll talk about that later. But if we let the market do its own thing, when we saw a shortage of toilet paper, the natural response would be to see the price increase until that shortage has alleviated. So the reason with shortages we see the price of an item increase over time is because consumers start being willing to pay more for that limited amount that's out there, that limited quantity supplied. And as that price goes up, sellers want to sell more, and then we fix our shortage problem. A surplus is the opposite. So surplus occurs when the quantity supplied outweighs the quantity demanded. So that happens when the price is too high. It's above the equilibrium. When the price is high, sellers want to sell a lot, but buyers don't want to buy that much. So the result will be that the price moves the opposite direction. Prices fall over time. That's actually what we've been seeing a lot in gasoline markets since the stay-home orders have gone into place. There's been all this surplus gasoline, which is very expensive to store, and so that's why we're seeing such low gas prices, is we're trying to bring that surplus back into equilibrium by lowering the price. So eventually prices fall over time because firms, or my sellers, suppliers, will lower their prices to get rid of their inventories. So I just want to show you what a shortage and a surplus looks like in our graph here. So here's our equilibrium, our happy place. If, say, the price in the market for gasoline was too low, say $1.20 per gallon, we can see that at this low price, if I look at where that corresponds on my supply curve, the quantity supplied, or the amount along the supply curve, is quite low. Maybe let's say it's 400 million gallons, versus where this price corresponds along my demand curve here at point B. At this low price, consumers want to buy a lot more because we've got a number that's out to the right here. So maybe this is 800 million gallons. So this difference right here is my shortage. So the difference between the amount my sellers want to sell at the low price and the amount buyers want to buy, that's going to be my shortage. And the result will be, over time, we are going to see prices increase because we're going to have that shortage occur, and consumers will start being willing to pay more for an item. And as sellers realize they can raise their price, they're going to supply a little bit more until we get back to this equilibrium. Alternatively, a surplus happens when prices are too high. So when a price is too high, if you look at where that corresponds on my demand curve, that's a low quantity demanded. But if you look at where it corresponds on the supply curve, that's a high quantity supplied. So the difference between the high quantity supplied, the amount sellers want to sell, and the only low quantity demanded buyers want to buy, that's going to be my surplus right there. So here, hypothetically, the difference between what sellers want to sell, 800 million gallons, and what buyers want to buy, 400 million gallons, this would be a surplus of about 400 million gallons of gasoline, the difference between these two. So when we have that surplus, sellers will realize they've got all this extra gallons of gas lying around, and they'll start dropping their price. And as they drop that price, the quantity supplied falls. As they drop that price, consumers want to buy more until the market clears right here. So that is it for the first part of supply and demand. Make sure to check out the second part to show how equilibrium shifts and something called the market mechanism. And let me know if you have any questions.